Hey everyone, welcome back to another video by Camroom 5. In today's video, we're going to continue with the concepts of electrochemistry, and I'm going to be teaching you about the three types of electrodes. We can call them the standard electrodes because this is what we are talking about right now. When I say electrode, an electrode by default has a half cell which has an electrode and electrolyte. So when I say electrode, electrolyte and the conditions, these three things have to be mentioned whenever I talk about electrode. So what's a standard electrode and what's a standard electrode potential? Basically, a standard electrode is an electrode which is connected with standard hydrogen electrode. It is connected with standard hydrogen electrode, also known as the SHE, She. So it's connected with standard hydrogen electrode at 298 Kelvin, 1 atmosphere pressure of the gases, and 1.00 mole per dm cube concentration. Yes. Moving on. When I say electrode, what I mean by that? I have basically three categories of electrodes, which can be obviously standard electrodes if the conditions are perfect. The first is a metal ion electrode, where a metal is in equilibrium with a metal ion. The second one is a non-metal ion electrode, where a non-metal atom or non-metal molecule is in equilibrium with a non-metal ion. The third category is two ions of same element, two ions containing same element in different oxidation states. Let me give you an example for each category. For example, the most perfect example I could think of about metal and metal ion is, let's suppose, iron 2 ions. Iron 2 ions which are aqueous, they gain 2 electrons and they become iron metal. It's an equilibrium between iron 2 ions and iron metal. Iron 2 ions is the metal ion and iron is obviously the metal atom. Another example we have is between chlorine and chloride ions. Chlorine is the non-metal gas, which is basically a non-metal molecule gaining 2 electrons, becomes 2Cl-, which is the chloride ion. Chlorine is the non-metal, which is the atom or molecule, and chloride is the non-metal ion. Third example, which is the trickiest one, let's pick a simple example for the most tricky category. Iron 3 ions gaining 1 electron to become iron 2 ions. It is the reduction of iron 3 ions. So both the ions here are aqueous and they are in equilibrium with each other. Both are ions, there is no metal. How do we create their standard electrodes? Obviously, we need a beaker for each category. Beaker is the must. So beaker is the first thing you draw. In the first category, you have an equilibrium between metal ion and metal. The metal ion should have a concentration of 1 mole per dm cube. I am putting a square bracket to show that the concentration is 1.00 mole per dm cube. I have in the second category chloride ions, so they should be also in a concentration of 1 mole per dm cube. The square brackets, again, I'm reminding you that it means concentration. In the third category, both of the species are ions, Fe3+ and Fe2+. So the concentration of both the ions should be exactly the same, 1 mole per dm cube, if it has to be standard electrode. For standard electrode, the condition is 1 mole per dm cube. In the first category, you have iron involved in the electrode, so you can make the electrode of pure iron. and even the wire can be made up of pure iron. So I can have iron electrode and I can have the wire made up of iron as well. In the second category, chlorine cannot make an electrode. Chlorine is not a conductor, it cannot act like a metal. So if you cannot afford a metal in this case, you cannot have the metal, platinum electrode is the best. So I am writing PT electrode. If you cannot have a metal in the electrode, then platinum is what you go for. And even the wire then should be made up of platinum. But where is chlorine? I did not involve chlorine. So if you want to involve the non-metal, then you go for a gas delivery system like this that I'm drawing right now. You have an inverted test tube with a delivery tube and you involve your gas at 1 atm pressure. In the last category, you can see that iron 3 ions and iron 2 ions are both ions, they are not metal. So again, I will go for platinum electrode. If you cannot make the electrode of the metal, then you go for platinum electrode, which is your last resort. Even the wire then should be labeled as platinum wire. Now, voltmeters should be represented in each category. These are electrodes, by the way. They can be completed with a salt bridge, and obviously on the other side you will have standard hydrogen electrode. These are half cells. These are not complete electrochemical cells. These three are half cells, and you will connect salt bridge, like left hand side I drew a salt bridge. The salt bridge and the voltmeter will be in the middle, and on the other side you will have standard hydrogen electrode if you want to make standard electrodes. 298 Kelvin is the temperature, and you can write it anywhere around your standard electrode diagram. So these are three categories of the standard electrodes. Type 1, where a metal was in equilibrium with the metal ion. Type 2, where the non-metal gas with a platinum electrode, and type 3 was when two ions were there. So guys, let's see this part. It says complete the diagram of the apparatus that can be used to measure the standard electrode potential. This is, by the way, standard electrode potential of the chromate hydrogen ion and chromium 3+ ion against the standard hydrogen electrode. Your diagram should be fully labeled to identify all apparatus, substances, and conditions. So let's allocate the left hand side electrode as the dichromate with hydrogen ions and Cr3+ ions. This is how we write them. This is the oxidized species and this is the reduced species. And let's allocate the right hand side wall electrode to standard hydrogen electrode. We know that both of these are ions. This is an ion, this is an ion. So the electrode cannot be a chromium, it has to be platinum. So I will draw platinum electrode, and even my wire is going to be platinum wire. This is going to be platinum wire. My substance inside the cell, the electrolyte, should be a solution. It should be a solution of what? It should be an aqueous solution of Cr2O7 ions concentration, and it should be Cr3+ ion concentration, both equal to 1.00 mole per dm cube. Both ions, both in square brackets. Square bracket means concentration. Square bracket is concentration. Then towards the right side, I know I have hydrogen electrode. Again, I cannot have an electrode made up of hydrogen. So again, I have a platinum electrode because hydrogen is again a non-metal. So this time again, I have a platinum electrode, PT electrode, and even the wire is made up of platinum. I have a voltmeter in the center like this, but I cannot forget that I need a setup to supply hydrogen gas because standard hydrogen electrode needs that, and I should provide hydrogen gas with a G, which means gas at a pressure of 1 atmosphere pressure. Salt bridge is already there, only my electrolyte is missing. My electrolyte should be hydrogen ions at 1.00 mole per dm cube. What one condition is missing, I can write 298 Kelvin around the setup. This is how I complete these kind of diagrams.